Hello, good afternoon, my dear student. Today we will discuss in details about a two-port network and its application. In last class, we have covered the topic RLC series resonant circuit, and its associated parameters, including half power bandwidth, half power frequency, quality factor or Q factor, and their interrelation. Okay, and you have noticed that a resonant circuit can be used as a frequency selector or frequency selective device for frequency selective device. On the other hand, it can also be used as a voltage amplifier. You have seen that the capacitor voltage or the inductor voltage, okay, VL or VC, is equal to Q times of the supply voltage, QV. That means you can design a voltage amplifier using a series RLC series resonant circuit. Okay, now we will discuss about two-port network and its associated parameter. Before going to discuss this topic, let me tell you the fundamental difference between two-port network and single-port network. Can anyone tell me the fundamental differences between a single-port network and a two-port network? Okay, can anyone tell me the difference between a single-port network and a two-port network? Differences between single port or one port, single port and two port networks. You know, networks and circuit are same thing. The two port network and single port network. What are the fundamental difference between single port networks and two port networks? We have already discussed about single port network earlier. Okay, in our previous classes we have discussed the theory part, and we have also calculated or solved mathematical problem associated with single port network. You know, single port network means it has only two terminals. The examples of single port networks are resistor, capacitor, inductor. Okay, but if the network has more than two terminal, I mean four terminal, then that such type of network is called two port network. That means it has two port, that is it has total four terminal. Let me write here the difference between two port network and single port. The single port, first point, single port network, a single port network, a single port network, single port means one port, single port network has two terminals, two terminals. On the other hand, two terminal, but a two port network has four terminals, four terminals. Okay, that means it has only one port, but two port network has two port. You just write inside bracket, that is two ports, two Okay. And another difference, you just write the examples of one port. Let me write here instead of single port. One port, example of one port network. One port networks are resistor, capacitor, and inductor. You know this element has only two terminal, inductors. Okay, and inductors. And examples of two port networks are are filters, matching network. Okay, and transformer itself a two-port network. Transformer. Okay, transformer. And you also write transmission line. This topic you will cover in your next transmission line. Okay, these are examples of two-port network. You write here. And third point, let me draw these networks. The single port network representation is shown below. Okay, let me draw it. If you draw box, okay, and you consider two single port, two terminals. Okay, and you consider the voltage drop. This point is V. Okay, and the current enters into the circuit is I1 through this upper terminal. You consider the current is I, and the current leaves through the lower terminal. You write, it will be same as the incoming current I. So you just use an arrow sign. This is entering current, it is entering current, and you just indicate the leaving current. This current enters and this current leaves. Both are same, entering currents. And this is an example of a single port network. This is your network. This is your network. This is your network. You can write, this is our Okay, no problem. This is our network. This is an example representation of a single port network. Okay, and now you draw the representation of a two port network. Two port network. Let me draw it. Let me here. Here, let me draw the two port network. Okay, the single port network, and now you draw the two port network. The two port network representation is shown below. Okay, uh, and you draw the two port network. It has four terminal, one input port and another, sorry, one input port and another output port. Okay, so let me draw this circuit. Sorry. Okay, and now you draw four terminal, one pair of input terminals, one pair of this is input terminals pair, and one pair of output terminals. This is our input terminals. It has four terminals, input port, and this is output port. Okay, output port. Okay, this is input port, this is output port. So for this case you consider input voltage is V port 1, you consider voltage V1, you consider V1, and output voltage is V2. V1 denotes V1, and output voltage, this voltage you consider V2, consider this one V2, sorry, V1, and output port voltage is V2, you just no, V2, and this current I1 and this current I2, you just let me write here. For two port network, V1 is input port voltage, and V2 is output port voltage. Okay, and you consider I1 current is input current and I2 current is output current. I1 current will enter into the network through this terminal, input terminal, upper input terminal, and it leaves from the network through the lower input terminal. On the other hand, the for port 2 in current I2 will enter into the circuit through the upper output terminals and it leaves from the circuit through the lower output terminal. And here you write V2 voltage, and this is V1 voltage input port and V2 voltage for output port. V2 voltage for output port. Okay, and their corresponding current is I1 and I2. I1 and I2 are are uh, input and output voltage are input and output port currents. Okay, this is the fundamental difference between single port and two port network. Okay, two port network. The single port network is a two terminal device. On the other hand, two port network is a four terminal device. Single port network has only single port or a pair of terminal. On the other hand, two port network has two port or two pair of terminals. Okay. Examples of single port networks are capacitor, inductor and resistor, because you know that these elements have only two terminals. On the other hand, examples of two port networks are filter, matching network. We have discussed about matching network when we cover the maximum power transfer theorem. Okay, you have noticed that maximum power can be delivered from source to load when load resistance equal to source resistance or Thevenin resistance of the network. That such situation is known as matched condition. So if you want to design a network, with help of the network you can match the input impedance and the load impedance. That network is known as matching network. Okay, matching network and transformer. You know what is transformer? Transformer are two types: step up and step down transformer. And then you another important two-port example of two-port network is transmission line. This topic you will cover in next semester in detail. Transmission line means the medium. It is a medium used to transmit a message or energy or signal from one point to another point, or you can say from transmitter to receiver side. Such type of line you can see can see surrounding of you as an example of open wire power line, optical fiber line, etc. Okay, but you will know in detail about this network in next semester. Now you just see their representation. Single port network, it has only two port. Okay, sorry, it has only one port and two terminal, and you see that there is a condition known as to port condition. Actually you see the current enter into the network is same as the current leaving from the network. The current entering into the network is same as the current leaving from the network. Okay, so for the two port network you see there are two voltage source at the output side and at the input side, V1 V2, and their corresponding current I1 I2. I1 current will enter into the network and it will leave from the network through the lower input terminal. Similarly, the current I2 will enter the network through the terminal of the upper terminal of the output side, and it will leave from the network through the lower terminal of the output side or at the output side. Okay, I hope you understand this the difference between single port and two port network, or one port and two port network, and their examples, etc. If you have any confusion, anyone, you can write. Okay, and now you know the main objective is to understand any device, network, circuit, or uh, uh, any combined circuit. Our main objective is to know their real-time application. Is to know their real-time application. If we know their real-time application, then we need to understand their theory, means working principle, uh, or structural description. Okay, so single port network, application of single port network, you know, we have discussed so far. The two port network, application of two port network, you just see filter design, matching network design, transformer, or a transmission line purpose. And one important application of two port network is the uh, AC analysis of transistor. Everyone has covered the topic transistor. You know the theory part of transistor, or you have also done experiment with a transistor. So therefore you have a good concept about transistor. So if you want to draw an equivalent circuit of a transistor, that time what type of parameter you use? What type of parameter have you used to draw the equivalent circuit of a transistor? Can anyone tell me? Equivalent circuit of a transistor. To draw an equivalent circuit of a transistor, what type of parameter we will choose? What type of parameter we will choose? I hope everyone knows about this parameter. This parameter is known as H parameter or hybrid parameter. H parameter or hybrid parameter, and it also known as mixed parameter. So H parameter is generally used to draw an equivalent circuit of a transistor, which is required for AC analysis of transistor. You have already covered this topic and also done experiment. Okay, now you can say the application of two-port networks. Two-port network, application of two-port network. Okay, now I will tell you what is parameter for a two-port network. Okay, I already told you that H parameter or hybrid parameter is used to draw an equivalent circuit of a transistor for AC analysis. So now let me tell you what is parameter. What is parameter of a two-port network? What is parameter of a two-port network? If you have any confusion or doubt to understand two-port networks or single-port network difference, you just tell me. Parameters of two-port network. Okay, now we will discuss about parameters of two-port network. Can anyone tell me what is the difference between variable and parameter? What is the difference between variable and parameter? I have discussed this thing so far in earlier class. The difference between parameter and variables. How many students? I hope everyone completed the experiment. Output characteristics of a transistor. Study of output characteristics or input characteristics of a transistor. Everyone has done this experiment. That time you have heard these two terms. You have heard these two terms. One is variable, another one is parameter. If you want to draw the output characteristics of a common emitter transistor, please respond to my question. Common emitter transistor, you choose output current, collector current along the y-axis and the output voltage. That means VCE, collector to emitter voltage, as the output voltage. Okay, these two are variables, collector current or output current and collector to emitter voltage or output voltage are variable. But what is the parameter? What actually terms you generally kept constant to draw these characteristics? The base current. The base current IV. When you want to study the output characteristics of a transistor NPN or PNP, whatever, you consider collector current and collector to emitter voltage are variable and base current as a parameter, because this base current is fixed for a particular set of collector current for different values of collector to emitter voltage. So therefore, you tell me the fundamental difference between variable and parameter. That means variable, the variable is a function of one independent terms, or you can say the value of variable is changing. On the other hand, the value of parameter is fixed. The value of parameter is fixed or constant. Okay, for a particular operation. This is the fundamental difference between variable and parameter. Now, and you just remember the example of variables and parameter for the output characteristics of a common emitter transistor, and you can consider common base transistor also or FET also. That time you can see the, if you consider FET, then you can see that VGS get to source voltage is considered as a parameter. Now let me tell you the difference parameter of a two-port network. Okay, you see two-port network has two port, one input and another output, and it has total how many variables? Total 4 variables. The network, two-port network, you just write two-port network has total 4 variables. 4 variables. These variables are 4 variables. Okay, two-port network has 4 variables. You just tell me the name of these 4 variables. The input voltage V1, input current I1, output voltage V2 and output current I2. Okay, V1, I1, V2, I2. These are associated with input ports. V1 and I1 and V2 and I2 are associated with output ports. Okay, output ports. So therefore, a two-port network has total 4 variables. But for a single port network has only 2 variables, V1 and I1. But for this two-port network is, you know, there is another port at the output side and its corresponding voltage is V2 and current is I2. So therefore, this port has 4 variables. So using these 4 variables, we can generally derive 6 equation, or if you consider mixed terms, then you can write 8 equation. Okay, so how do you derive the equation that actually relate the the dependency between input and output variables. Okay, input and output variables. So you just uh, write the equation, okay, which relates the dependency between input and output variables. So among these four variables, you can choose two as an independent variable and another two as dependent variable. Okay, out of these variables, we can consider, we can choose we can choose two variables as independent and another two variables as dependent, okay, variable. And we can write the different input output difference equation, okay, different equation by using the dependent and independent variable. I mean, we can write the equation of dependent variable in terms of independent variables. Okay, we have two types of variable, independent variable and dependent variable. You know that the dependent variable, the value of dependent variable depends on independent variable. So we can represent or we can express dependent variable in terms of independent variable. So if you want to express dependent variable in terms of independent variable, okay, then you will get at least four, six, eight equation, okay, at least eight equation, okay. And the coefficient associated with independent variables are known as parameters, okay, are known as parameters, okay. So therefore you just write, therefore therefore we can express the dependent variables variables in terms of independent variables, independent independent variables and the coefficients associated with independent variables are known as parameters, okay. So therefore it is clear to us what is parameter and what is variable for a two-port network. Now we will derive the different equation of two-port network in terms of this parameter. There are total four parameters, okay, in two-port network. Let me write it. There are total four parameters. Associated with two-port network. These parameters are first is Z parameters. Second one, Z parameter, it also known as Z parameters or open circuit impedance parameters. Okay, you just note down it. Then Y, it is all Z means impedance parameter. Y or admittance parameter. Y parameters or short circuit. I will discuss about this. Why is it called open circuit and short circuit? I will tell you later. Short circuit admittance parameters, okay. And you know that impedance parameter is reciprocal of admittance parameter, or admittance parameter is reciprocal of impedance parameter. Third one is H parameter or just write in small letter, H parameters or hybrid parameters. Okay. And fourth one is ABCD or mixed parameter. It also known. This is known as mixed parameter. This is also known as transmission parameter. You just write here H parameter or hybrid parameter, and it is also known as mixed parameter. Mixed parameters. But this fourth one is ABCD or transmission parameters. Okay, so we will try to understand about these four parameters and their interrelation. Okay, and their interrelation. Z parameter or open circuit impedance parameter, Y parameter or short circuit admittance parameter, H parameter or hybrid parameters, and it also known as mixed parameter, and final one is ABCD or transmission parameter. So first we will discuss about Z parameters. Any doubt regarding parameter and variable? What is parameter? What is variable? Okay. Then let me tell you about Z parameters. Okay. Z parameters. Okay. I already told you that parameter is nothing but the coefficients of independent variable associated with the two-port network equation. The equation relates the dependency of input and output variables. And I have already told you that there are two types of variables. One is independent and another one is dependent. We can express dependent variable in terms of independent variable. So first you write the relation between input and output variables. Let us consider that I1 current and I2 current, input port current and output port current are independent variables, and input port voltage and output port voltage V1 and V2 are dependent variables. Okay, you just write it. Let us consider that I1 input port current and I2 output port current are independent variables. On the other hand, independent variables, but input port voltage V1 and output port voltage V2 are dependent variables. Okay, you first consider it, then you write the equation, the dependency between V1 and I1. We can write equation in terms of this equation. You write in terms of matrix from, you write V1 V2, okay, V1 V2 equal to, you just write here comma in matrix form, no problem, comma, that means you can write in column wise V1 by V2, this thing equal to, you can write, let me write it, V1 by V2 and you bracket, this is matrix from, equal to, you can write Z11 Z12 divided to Z12 into Z21 Z22, you just close the matrix, equal into, you can write multiplication of I1 and I2, okay, you just write matrix from, okay. Here we have expressed the voltage, input port voltage and output port voltage in terms of input port current and output port current. Okay, V1 V2 are the input and output port voltage, I1 and I2 are input and output port currents. Okay, now we can write this matrix from in terms of equation. Let me write it. We write the equation will be V1, you write yourself, you just take multiplication this matrix with that matrix, so we can write Z11 into I1 plus Z12 into I2. Okay, this is equation 1. You write it. If you have any doubt, you write in your chat box. V2 equal to, you can write Z21 I1 plus Z22 I2. You can consider this variable. You write it in subscript from. It's good subscript from. You just write yourself. Okay, Z11. If anyone has any doubt regarding this equation, you tell me. Then we can write Z2 1 I1 Z22 equation 2. We just write as equation 2. Okay, everyone carefully understand this concept, because in next lab class we will experimentally verify these things. Okay, the output and input relation through z parameters and y parameters and other parameters. So you just try to understand the theory part. Okay, and you have any doubt, you just write in your chat box. Okay, so now we can write V1 and V2 in terms of I1 and I2. Therefore, equation 2 signify the dependency of voltage variable on current variable. Okay, V1 equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2. Now, if I ask you that you calculate you write the expression of Z11, Z12, Z21, Z22 in terms of V1, V2, I1, I2. Okay, next you do it yourself. If you face any problem, I will help you. You just write Z11, what will be the value expression of Z11, then Z12, Z12, then Z21, Z21, sorry, Z21, and finally Z22. Okay, you calculate it. You write the expression of these parameters. Everyone try to write the expression of Z11, Z12, Z22, Z21 from the equation 1 and 2 in terms of voltage and current. You know that Z, I already told you that Z is nothing but the impedance parameter, open circuit impedance. Impedance means what? The ratio of voltage and current. The ratio of voltage to current. So you just write yourself the expression of Z11, Z12, Z21 and Z22. Write it. If you face any problem, I will help you. Okay, you just let me copy this thing. Student, write the expression of Z11, Z22, Z21 and Z22. Okay, anyone can solve this problem? Anyone can write the expression of Z11, Z12, Z21, Z22? Okay, let me write. Let me write this. Okay. Now, uh, our first objective is to uh, write the expression of Z11. If we want to calculate, or if we want to write the expression of Z11 in terms of current and voltage, then what we will do? We will consider the output port is open circuit. That means I2 is 0. So Z11, we can write Z11 equal to V1 divided by I1 at I2 equal to 0, or output port is open circuited, is open circuit. Okay, I2 is 0. If you make I2 0, then this term is 0. and then you can write V1 by I1 equal to Z11. Okay, then you tell me what will be the expression of Z12. Z12. You tell me what will be the expression of Z12. Z12. Okay. If you consider output port is open, that means the current I2 open circuit means what? Current is 0. Current is 0, voltage is infinite. The current is 0, that means the second terms of equation 1, the second terms of equation 1, left hand side, I mean left hand side part, is equal to 0. So therefore you can write Z11 equal to V1 by I1, that I2 equal to 0 or output port is open circuited. Now you tell me the expression of Z12. Expression of Z12. So you see, if you consider I1 is equal to 0, then you can write Z12 equal to V1 by I2. That means input port is open circuited. Try to understand this point. So you can write V1 divided by I2 at I1 equal to 0, or input port is open circuited. Okay, no problem. And from equation 2 we can write the expression of Z21 equal to V2 divided by I1 add I2 equal to 0, or output port is open circuited. Okay, and Z22 equal to, we can write V2 by I2 at I1 equal to 0, or input port is open circuited. Okay, we can write or V2 I2 for I1 0. Yes, good. Everyone write the expression of Z11, Z12, Z21, Z22 in your chat box. Okay, and you see that these parameters actually are ratio of voltage and current, maybe output voltage or input voltage, or output current or input current. Okay, so that means these parameters represent impedance value, and its units is ohm. Therefore you can write the value of Z11. If I give you the numerical values, then you can write Z11 equal to X ohms. X may be a numerical value 2, 4, 2.5, whatever. Okay, so therefore the unit of this parameter, Z parameter, is ohm. Okay, or unit of resistance. Okay, now you see Z11 equal to V1, and V1 ratio of V1 to I1, that means input port variable. This impedance is known as input port driving impedance. I already discussed about driving point impedance and transfer impedance, and we have derived the expression of driving point impedance and transfer impedance for T type network and pi type network. Okay, you just remember it. For T type network, arms impedance are ZA, ZB, ZC. That case we have derived the driving point impedance as well as transfer impedance. Okay, and for this two port network you see that the input port impedance or driving point impedance equal to V1 by I1, input port driving point impedance. If you consider Z22, then you see that this is associated with output port variable V2 I2. That means this is also known as driving point impedance, output port driving point driving point impedance, output port driving point impedance Z22. Therefore, Z11 and Z22 are driving point impedance for input port and output port. Now you see Z12 and Z21, you see that these parameters actually value depend on the input port variable as well as output port variable, dependent and independent. Okay, input port variable and output port variable. That means these impedance are known as transfer impedance. There is a transfer, okay, between input and output. Okay, this impedance Z12 and Z21 are known as transfer impedance. Okay, Z, if you consider Z12, you see that V1 divided by I2, then when output is feedback to input, this impedance is known as reverse transfer impedance. And Z21, you see that V2 by I1, okay, forward, this impedance is known as forward transfer impedance. So let me write this thing. You just write V2 in capital letter. So this impedance also known as, it is also known as driving input port driving point, input port driving point, driving point impedance, no doubt. And you write, just hold it, write capital letter. And this Z22, it is also known as output port driving point impedance. You just press in output port driving point impedance, and you see these two are transfer impedance, and this impedance is known as, it is also known as uh, forward feed forward or forward transfer impedance. For, note, this is backward. V1 by I2, V2 by I1 forward. This is reverse. I2 is feedback. Okay, this is known as reverse transfer impedance. Okay, reverse transfer impedance, and this one known as, and this one known as forward transfer impedance. You see I1 is input current, it will flow to outside. So forward transfer impedance. Any doubt to understand these parameters? You see, we have considered a two-port network. The two-port network has total 4 terminals. Therefore, okay, thank you. What about others? Uh, two-port network, and therefore it has total 4 variables: V1, V2, I1, I2, input port current, output port current, input port voltage, output port voltage. And in this context, you must remember that there is a condition associated with two-port network, which is known as, Orijit, thank you, which is known as two-port condition. Two-port condition means what? Whatever the current enters into the network through upper terminal of port 1, the same amount of current will leave from the network through the lower terminal of the port 1. I mean, if current enter through port 1, the upper terminal, then the current will leave through port 2, I mean terminal 2 of port 1. Similarly, the current whatever will enter into the circuit through port 2, through upper terminal of port 2, the same amount of current will leave through the lower terminal of port 2. This is known as two-port network condition. Okay, two-port network. Okay, thank you, Nivedita. And after that, we have derived the relation between independent and dependent variables. And in this context, we have discussed about the difference between variable and parameters. Variable, the name implies that its value is changing, not fixed. On the other hand, the value of parameter is fixed for a particular function or operation, and you can easily understand about parameter and variable if you remember the output characteristics of a transistor. Okay, output characteristics of a transistor. After that, we have realized that a two-port network has total 4 parameters. These parameters are Z parameters or impedance parameter or open circuit impedance parameter, admittance parameter or Y parameter or short circuit admittance parameter, hybrid parameter or mixed parameter or H parameter, and ABCD parameter or transition parameter. At first, we have tried to understand about Z parameter or impedance parameter. So to understand about Z parameter, we need to write the equation between independent and dependent variables. In this case, we have considered the voltage terms are dependent variables and current terms are independent variables. So first we have represent this relation as a matrix form, and later on we have written the relation as a equation form. Okay, and from these two equation we have derived the expression of Z11 different impedance parameter Z11, Z12, Z21, Z22, and these parameters are classified into two categories. One is driving point impedance, another one is transfer impedance. The transfer impedance are two types: reverse transfer impedance. If I2 is taken as the ratio, is taken as denominator, okay, and if I1 is taken as denominator part, then it is known as forward transfer impedance. Means I1 actually input side current, that's why forward, it goes towards outside, and output current I2, it is actually, if we consider as a feedback, then we can write V1 by I2, that means reverse case, okay. And let me tell you one important concept about this circuit is two-port network is said to be symmetrical network if output driving point impedance is same as input driving point impedance. Okay, that means Z11 equal to Z22. You just remember this thing. A two-port network is said to be symmetrical network if its output driving point impedance is same as its input driving point impedance, that is Z11 equal to Z22, then we can say that the circuit is a symmetrical circuit. Okay, if you have any doubt, you just write in your chat box. Okay. Thank you everyone. Let me stop today's lecture here. If you have any confusion or doubt, you write in your chat box. Okay. In next lab class, we will calculate the values of these parameters. Okay, experimentally. Okay, so you just write it. You just read out this topic carefully, and if you have any confusion or doubt, you can ask me in lab class. No problem.